Hello students, welcome to Educate. In the last class, we have discussed about the preparation of amines and we have also discussed about the questions. These questions I have not solved but if you will try at your home, you will solve this question very easily. So I hope everyone could solve these questions, but if anyone will feel difficulty, then may ask in the comment box. Definitely, I shall make another video to solve this question. Otherwise, there will be unnecessarily consumption of the time. Now we proceed from the physical properties. Physical properties, in case of physical properties, we discuss about the melting point, boiling point and solubility, usually that, and the density also. So let's see here, first one about the melting point and boiling point. So amine here that will be bonded with each other through hydrogen bonding. The molecules of amine will be bonded with each other through a strong intermolecular hydrogen bonding. As a result, the amines will possess very high melting point and boiling point. How is the hydrogen bond formation? Let's see. Like this one here. So this hydrogen could bond it here like this. Another amine molecule that can be bonded like this. As there is lone pair phaeton at the nitrogen, lone pair phaeton at the nitrogen, so that can be formed here. So due to intermolecular hydrogen bonding, due to intermolecular hydrogen bonding, the amines possess high melting point and boiling point. You already know in the alcohol chapters also. When you will have to compare the order of melting point and boiling point among the primary, secondary and tertiary amine, then obviously in primary amine there is 2 hydrogen, in secondary amine there will be only 1 hydrogen, like this one here. In addition to that, there will be steric hindrance also. In the case of secondary amine, there will be more steric hindrance. So hydrogen bond strength of hydrogen bonding will be more in case of primary amine, and then after it is secondary amine, and then after this in tertiary amine there is no hydrogen bonded to the nitrogen and steric hindrance is also high. So that's why the order of melting point and boiling point will be 1 degree amine highest, then after secondary amine, and then after tertiary amine. That is 1 degree, 2 degree and 3 degree. That is here. So that is very easy. Then after is the amines are also soluble in water. Like alcohol, the amines are soluble in water as well as in organic compounds. Amines are soluble in water as well as in organic compounds. So organic compounds, the solubility will be due to the alkyl part, and in water, why it is soluble? So let's see here. Water can also with water it can do hydrogen bond formation. So the amine molecules can do hydrogen bond formation with the amines can do hydrogen bond formation with water. That's why the amines are soluble in water. How is that? As for example, again I am taking ethanamine. So here is lone pair phaeton, hydrogen and two lone pair phaeton at the oxygen of the amine. Here also lone pair phaeton. So this hydrogen will to be attracted toward this nitrogen. This hydrogen will attracted toward this oxygen. In the same way, this hydrogen will be attracted with other water molecule. So the amine molecules are doing hydrogen bond formation with the water molecules. That's why the amines are soluble in water. The amines are also soluble in organic solvent because the alkyl part bonded to the amines, that is non-polar. So it can dissolve in non-polar solvent also. So that is okay. And okay guys, easy. That was about the physical properties, that is about the solubility in water and their order of boiling points. Okay, this one here no need to mugged up, only just consider about their solubility. Okay, order of melting point and boiling point. Okay, written. So order of solubility. So 1 degree amine, why this one? Because in 1 degree amine, the number of hydrogen atom is 2 and there is least steric hydrogens. So it could do hydrogen bond formation with water molecule more effectively compared to that of the secondary amine as well as from the tertiary amine. In the same way, among secondary amine and tertiary amine, the secondary amine could do hydrogen bond formation with water molecule more efficiently. That's why secondary amine will be more soluble than the tertiary amine in water. So that is here. Okay. Now let's see. This is a table. Just goes through the. Just go through when butanamine here number of carbon atom is 4. Here also number of carbon atom is 4. Here also number of carbon atom is 2 and 2 4. Number of carbon atom is 4 4. Everywhere number of carbon atom is 4. So when you compare the order of boiling point among alcohol and amine, among amine here and alcohol. So alcohol can do hydrogen bond formation more efficiently compared to that of amine because oxygen is more electronegative than that of nitrogen. So alcohol molecule extent of hydrogen bonding is more, or the strength of hydrogen bonding is more in case of alcohol. That's why alcohol possesses greater boiling point than that of amine. either 1 degree here. Now that was about the comparison of the order of boiling point between the amine and the alcohol, in which we have observed that the alcohol possesses greater boiling point than amine. And the reason is that the alcohol molecules are bonded with each other through a stronger hydrogen bonding compared to that of the amine, in which the strength of hydrogen bonding is less. So now let's see here among primary, secondary, tertiary amine. So let's see here in primary amine, order boiling point is that much. In secondary amine, in primary amine boiling point is this one, secondary amine this one, and tertiary amine is this much. So there is decrease in primary amine, okay, secondary amine, tertiary amine, and it is hydrocarbon. So obviously hydrocarbon, boiling point of hydrocarbon is least. It is of hydrocarbon. So boiling point of hydrocarbon will be least, and then after amine, and then after the alcohol. So maximum boiling point is of alcohol, then after of amine, and in amine, primary amine will possess greatest boiling point, then after secondary, and then after tertiary. And the hydrocarbon will possess, this one is hydrocarbon. So boiling point of hydrocarbon will be least. Okay, that is the comparison. And in the first chapter, I have also informed you about the order of boiling point when the number of carbon atom will be same. That was about the physical properties. Now let's see about the chemical properties. Chemical properties, first one is here basic strength. So basic, more basic or less basic, that is about the basic strength. That will be the chemical properties here, acidic or basic. But order of melting point and boiling point, that was the physical properties. Let's see here about the chemical reactions here of amines. First one is basic character. How's it is basic, that has been shown in this reaction. Here it's a basic, amine is basic, that's why it has reacted with acid, because acid will react with base and base will react with acid. So when acid has been taken, then amines react with that acid and there is formation, and so in this case there is formation of salt. So since amine reacts with acid, so it proves that the amine are basic. Like as for this example, in the same way aniline reacts with acid, so form aniline chloride. So it indicates that the amines are, that is either aniline or the aliphatic amines, they are basic. About this one, when we will have to compare about the basic strength of ammonia and the amines. First one, this one is what? Like this amines here, when OH minus ion, so amine form here. That is, now how to find out that it's a basic strength? What will be the basic strength? More basic or less basic? That could be calculated. If you will have to calculate, that is which one is more acidic or more basic, then we compare their pKb value. pKb. Okay, if you will have to find out that if you will have to compare the acidic strength of two acids, which one is more acidic, which one is less acidic, and by how much, then you will have to compare their pKa. Two process here, pKb and pKa, as well as by Kb and Ka. That means when you will have to find out the basic, when you will have to find out the basic strength of a particular base, then you will have to find out their Kb, means dissociation constant of base. How is that calculate? If you have studied the chapter equilibrium of class 12th, very easily you will find out. But again, maybe some students have not studied so much sincerely in the class 11th. So here also I am discussing. Okay, some here has been hint has been also provided in the NCERT book of this 12th class in this chapter. So about that we discuss. Guys, if Kb will be more, more be the Kb, means dissociation constant of the base will be more, then more basic be the compound. And if pKb will be more, then less basic be the compound. Okay, here it's the thinking base. I shall discuss about this one point also. So first of all, let's see about this pKb, how we calculate Kb and this, because there is already in the books given provided. So it will not take so much time to discuss about point this. So this amine here this amine, that's when dissolved in water. This amine dissolved in water. So what happened? It's a base, so it can accept H plus ion from the water molecule. So from water molecule here, so it is H plus and OH minus ion. So H plus, so amine is a base, so it could accept the proton. So H plus will be accepted by this NH2. So there will be formation of iminium ion. There will be formation of this iminium ion and this OH minus ion. Okay, it indicates that this reaction is taking place. So this one, how we calculate the equilibrium constant? So equilibrium constant, when we will have to calculate, then we take the concentration of product. In the product there is iminium ion as well as the hydroxide ion. So iminium ion and the hydroxide ion, concentration of product upon concentration of reactant, and in the concentration of reactant there is amine and water. So this one, concentration of product upon concentration of reactant, that's what this has been given. Now what happened, since the amount of amine since very less amount of amine could be dissolved in water, that's why we can say that the concentration of water will be in infinity compared to that of amine. So amount of water is too much high than that of amine. So we can, during this course, few molecules from here have lost the proton. So we can say that the concentration of water is constant. Just like that, it out of 1 lakh rupees, if 1 coins will lost, then predicting that how much money has been lost, that will be, feeling that it will be difficult. So same here, we find out the concentration of water as constant, since the concentration of amine because during that course few water molecules will lose their electron, will lose their proton. So concentration of water will be constant. So when equilibrium, it is constant already, and the concentration of water, that is also constant. So product of the equilibrium constant of this base, this one, equilibrium constant of ammonia of this reaction, and the concentration of this water, that will be also constant. So that constant will be called Kb. So Kb concentration, this one, so that is called Kb. And how's the pKb? As you calculate pH, as you know, pH is equal to minus log H plus ion. In the same way, pKb will be equal to minus log Kb. pKa here not required, but also pKa, that will be also equal to minus log Ka. Okay, this one. So what happened? Just watch out here. Among 5 and 3, 5 is greater than 3. But when negative sign will insert here, then minus 5 will be less than that of minus 3. So if Kb will be more, then more basic with the compound. Kb will be more, then more basic. The compound will be more basic. And if Kb will be less, then compound will be less basic. But Since negative sign here in pKa and pKb, here minus sign has been inserted. So more with the value of pKb, less basic with the compound. Okay, so let's see. One point is that now let's compare the basic strength of ammonia. That means let's compare ammonia. You know that ammonia is also basic and amine is also basic. So ammonia is a stronger base or the amines is a stronger base. That we are comparing. So when watch out here, this one done. Then watch out here, the pKb value of ammonia is 4.75. That means pKb for ammonia, that is 4.75, and pKb for amines, that ranges from the pKb value of amines, that ranges from 3 to 4.22. So obviously pKb value is more for ammonia compared to that of amines, from 3 to 4.22. So pKb value for ammonia is greater, so its basic strength will be less. Here also given pKb value of ammonia 4. Okay, this one and this. So that's why amines is more basic than ammonia. Okay, therefore okay guys, easy here. Now proceed. This is the table given. Table here, that is okay. About this table we discuss after discussing from here. Okay, let's see. Here basic strength we will have to compare, that is in aqueous state and in vapor phase, in both the cases. Just firstly watch out on the this one. In aqueous state, aqueous phase, I tell you, that was the experimental proof that amines are a stronger base than ammonia. By the experimental proof, you have find out their pKb value of ammonia and that of the amines. Like ammonia, the pKb value was 4.75, and of the amines, that was ranged between 3 and 4.22. But what's the reason there? Now let's think about what's the reason that amines are more basic than ammonia. Listen. In amines here, why amine is basic? First of all, why amine is basic here? So amine is basic because there is 2 lone profile electron at the nitrogen atom. Due to the presence of a lone pair of electron at the nitrogen atom, amines are basic. And in ammonia here, in ammonia is more basic because there is a lone pair of electron at the nitrogen atom and this one. And when we compare about the amines here, so here also in amines there is a lone pair of electron at nitrogen. But in case of amines, in addition to the lone pair of electron, the alkyl group also donate their electron to the nitrogen due to plus I effect. What is that? In case of amines, the electron cloud density at the nitrogen atom is greater due to the plus I effect of alkyl group, and hence the amines is more basic than ammonia. Okay, so write that reason. You may write that also. Due to plus I effect, amines are more basic. Due to plus I effect of alkyl group, amines are more basic than ammonia. Okay, now let's see about the among primary, secondary and tertiary amine. The basic strength of primary, secondary and tertiary amine. Let's compare the basic strength of primary, secondary and tertiary amine. So there will be two conditions. One is that when amine will be in aprotic solvent, when amine will dissolve in aprotic solvent, or if it is in vapor phase. Same order if that will be in the aprotic solvent or in vapor phase. And second is that when amines will dissolve in water. Actually, there will be difference there of the basic strength of amines in when it will dissolve in aprotic solvent or in vapor phase. That is same condition. And second one will be when amine will dissolve in water. So when this amines will dissolve in aprotic solvent or when amine will be in the vapor phase, then the basic strength of amines will depend on only one factor. When amine will be in vapor phase or when it will dissolve in the aprotic solvent, then the basic strength of amine will depend on only one factor, that is the electron cloud density at the nitrogen atom. Okay, but when amine will dissolve in water, and then after you will have to compare the basic strength of amine, then you will have to consider the two factors. One is the electron cloud density at the nitrogen atom, and second one is the order of solubility of amines in water. Okay, so about the aqueous state, we discuss about the order of basic strength in aprotic solvent or in vapor phase. So let's see. So what you find out that in case of amine, suppose here 1, 2, 6 carbon of I am taking of amines having number of carbon atoms 6. So here electron will provide from this side. So electron goes from the alkyl group from one side. Second one is here when there will be 2 alkyl group attached here. So in secondary amine, the electron will supply to the nitrogen from two sides. And in tertiary amine, the electron will supply to the nitrogen from three sides. This alkyl will donate the electron, this alkyl group and this alkyl group. So, and you know that in a protein solvent or in vapor phase, the basic strength of amines depend on the electron cloud density at the nitrogen atom only. So here electron cloud density is maximum on the tertiary amine and minimum in primary amine. That's why the tertiary amine will be most basic and the primary amine will be least basic among the amines. And it's also a fact that of either that is primary, secondary or tertiary, ammonia will be less basic than that. So order of their basic strength will be, that will be 3 degree amine, 2 degree amine, 1 degree amine, and least is for ammonia. Okay, here table has not been given because questions will not ask on this factor. Maybe chances of asking this question should not be denied, but this concept is so much easy that in from here the questions oftenly not asked. But we should not deny its importance. Okay, now let's see about the basic strength in aqueous phase. Now, in aqueous phase, the basic strength of amines depend on two factors. One is the electron cloud density on the nitrogen atom, and the second one, the order of solubility in water. So compare first of all to both of them, and then after we will compare. So let's see. So write that one point here, right? That is you. Okay. Second one is the okay guys, already which I have discussed here, that's I have written also. Now let's see. That's there was no tension about when you have to compare the basic strength of amines in aprotic solvent or in vapor phase. Now, when you have to compare the order of basic strength of amines when it will dissolve in water, then firstly you have to compare the order of electron cloud density on the nitrogen, and second one you have to compare the order of solubility of amines. So let's see. What is here? You already know that in case of primary amine, electron will supply from only one side. So in primary amine, electron cloud density will be least, and in tertiary amine, the electron cloud density will be most. So 1 degree amine, electron cloud density will be least, then after 2 degree, and then after 3 degree. Now let's see about the order of solubility. So let's say here, you already know that in amines, primary amines, strength of hydrogen bonding will be more. In case of primary amine, strength of bonding, hydrogen bonding will be more, or extent of hydrogen bonding is more. Why? We have discussed here in physical properties. And of the tertiary amine, that is least. Because in case of primary amine, there is 2 hydrogen. So it can do more hydrogen bond formation. And in case of tertiary amine, there is no hydrogen bonded to the nitrogen. In addition to that, there is steric hindrance also. So extent of hydrogen bonding in tertiary amine is least, and that's why that will be least soluble in water. So that means 1 degree will be maximum, then after 2 degree, then after 3 degree. That is here 3 degree, 2 degree and 1 degree. Now the basic strength of amines depend on the 2 factors. So, and both the factors are opposite to each other. Since the strength of the basic strength of amines depend on 2 factors when it will dissolve in water, and both the factors are opposite to each other. So we cannot say that which amine is more basic and which one is less basic by simply watching the compound. So that will be the basic strength of amines when it will dissolve in water will be an experimental quantity. Okay, and so of methylamine and ethylamine, that is in your syllabus. So let's see. In case of ethylamine, always 2 degree amine. In case of ethylamine and in case of methylamine also, the 2 degree amine is more basic. That is, among these 3 types of amines, when you have to compare among the ethylamine, then the 2 degree ethylamine will be most basic, and here then after is 3 degree amine, and the 1 degree amine will be least basic. In case of ethylamine, in case of ethylamine, the 2 degree amine will be most basic and 1 degree amine will be least basic. In case of methylamine also, the 2 degree amine will be most basic, but 1 degree amine will be more basic than that of 3 degree amine. So difference arises only at this one. So the amines having one carbon atom, that will be more basic. That means in primary amine here, that you may, by that technique, you may keep in your mind. If you will get confused in the examination, then that means 1 degree amine will be more basic, in which the number of carbon atom will be 1. Okay, so that is here. So that is here by this value. No technique, you will have to mark up this one. Keep in the mind. Revise 2, 3 times, 4 times. That will remain in your memory. And here one is the 2 degree amine will be most basic, and in case of methylamine, 1 degree amine will be more basic than 3 degree amine. And it's also a fact, either in ethylamine or in the methylamine, that will be more basic than ammonia. That is here. Okay guys, any problem here? Now let's see about this one. Now let's see we compare the basic strength of aniline with ammonia, or the basic strength of aryl amine with ammonia. Let's see. Let's see ammonia here, and it is again I am reiterating that the ammonia is more basic, or ammonia is basic due to the presence of lone pair of electron at the nitrogen atom. And in case of aniline, let's see what happened. And alkyl amine was more basic. We had observed that alkyl amine is more basic than ammonia, and the reason was the plus I effect of alkyl group. In case of aryl amine, let's see what happened. When you draw the regenerative structure of aniline, it will be here. Positive charge on the nitrogen. Remaining regenerative structure you draw by yourself. One regenerative structure I am drawing. Remaining you draw by yourself. So what is here? There is positive charge on the nitrogen atom. So the electron cloud, so the lone pair of electron present in the nitrogen, the lone pair of electron present at the nitrogen atom, that will delocalize inside the benzene. As a result, the electron cloud density at the nitrogen atom will be less, and hence it will be less basic than ammonia. And this effect is called here plus R effect. Plus R effect. So in case of aniline, electron cloud density at the nitrogen atom decreases due to plus R effect, and hence aniline is less basic than ammonia. Okay guys? Okay guys, very easy. In the examination, these points are important for you about the give reason type, and both for the 12th board examination as well as for NEET and for the main examination. There is equally importance for all the three examination. In the previous number of questions, I have told you that a particular question or a particular concept is more important for which exam. But here I cannot say that for which examination it is more important. There is equal importance of this topic for the all the examination. So one is that reason and second one is order. And order is asked frequently in NEET examination as well as in main and in 12th board examination. Okay, and frequently asked question is about aqueous state. But it not means that in vapor phase or in aprotic solvent, the order of basic strength will not ask. There is probability of asking the questions from the basic strength of amines in aprotic solvent or in vapor phase or in all the three formats also, and but less chances in asking in the IIT main examination. And condition is that if other questions are difficult, then only that type of question will ask, because that concept is quite easy. But in 12th board examination, if the physics paper or the math paper will be difficult, then there will be a probability of asking the questions about the basic strength of amines in aprotic solvent or in vapor phase. Now let's see. So that was we discussed. Now very easily you could compare here. Okay, so let's see about the basic strength here. Compare this highest is of 9.38 and then after 9.30. So let's see here in benzylamine pKb value is highest. pKb value is highest, that means it will be least basic. So that's why benzylamine here, that is least basic, so their basic pKb value will be most. Then after is N-methyl aniline, that is basic strength pKb value is less than that of benzylamine. So what's the reason? Let's see here. In aralamine here, N-methyl aniline means methyl attached here. So what happened? This methyl part, this methyl group will donate their electron to the nitrogen here. So, and this benzene take the electron. And in case of aniline, only one is phenomena is taking place, and that is benzene take the electron. In case of N-methyl aniline, the benzene is taking electron and the methyl group is donating the electron. And in case of aniline, here benzene is taking the electron. So obviously here electron cloud density will be more. So electron cloud density will be more. So that will be more basic. More basic. So pKb value will be less. So here pKb value is less because N-methyl aniline is more basic than aniline. Okay. Now next higher point is about 8.92 and dimethyl aniline. Okay. So in and dimethyl aniline, what will be there? Here there will be two methyl group bonded to this nitrogen. So electron will come from this methyl and this methyl. So electron will come from two sides and it will delocalize towards the benzene. So obviously in this case also the electron cloud density will be greater. So electron cloud density has increased, and that is more than that of in case of primary amine or the N-methyl aniline also. So that's why N dimethyl aniline is more basic than N-methyl aniline. So that's why pKb value is less, because N dimethyl aniline is more basic. More basic means its pKb value will be less. So that's why. That was the reason. So this we did, this did. Then after the higher point is 4.70. It is phenylmethenamine. So let's draw the structure phenyl and methenamine. So main here is draw the structure methenamine, means NH2 is bonded to a carbon atom. So NH2 is bonded to a carbon atom of open chain, and that is bonded to the benzene. So what is happening here? This carbon here, nitrogen is not directly bonded to the benzene. Nitrogen is not directly bonded, or draw the structure like this one also. So in this case, from the benzene here, this benzene will take the electron from methyl, and here plus I effect also. So obviously electron cloud density will be more here. So it is bonded, not bonded to the benzene, it is bonded to the open chain. But this methyl group will take the electron from that also. So electron cloud density will be there, and watch out, compare. The difference is the value of pKb. So when the NH2 is attached to the open chain carbon, then basic strength is very high, and that's why pKb value will be very less. And then after difference of these one, primary, secondary, tertiary, that is not so much compared to that of aryl amine. Now let's see, next higher is this one, methenamine, obviously, and then after is here 3.29, this one, that is ethanamine. So in aqueous state you have studied there that in methanamine basic strength is more, and in ethanamine basic strength is less. Sorry. In ethanamine basic strength is more. Why? Because alkyl group is here bulkier. So alkyl group is bulkier, so it can give the electron more compared to that of methanamine. So that's why ethanamine is more basic. Ethanamine is more basic than methanamine. That's why its basic pKb value is less. Then after this N-methyl methanamine. Why this one? Because it's the secondary amine. So like that here. Okay. So very easy it was about the basic strength. Okay, one reason here that why aniline here and why aniline is less basic than ammonia. So because in case of aniline also, anilinium, after gaining the electron, there will be formation of anilinium ion. When aniline will gain the electron, here it's aniline, when it will gain the electron, here proton, sorry, not electron, proton. So there will be formation of anilinium ion, and of this anilinium ion, there will be only 2 resonating structure. In aniline, there was how much? 5 resonating structure. So number of resonating structure is less. So anilinium ion is less basic than ammonia. So that is okay guys, that was about the basic strength of aniline and amines. In the next class we will discuss this question only, and then after the other reactions of the aniline. It's all for this class. Thank you, Team Educate.